First illa illa first start pannalam. Good morning to all. I am Dr. M. Kasthuri, Assistant Professor of Mathematics, DKM College for Women. In this lecture, I am going to explain about the sequencing problem for 3rd BSc Mathematics. So what is meant by sequencing? A problem in which it is necessary to determine the order or sequence of jobs in which they should be performed so as to minimize the total elapsed time is called a sequencing problem. So next I am going to tell about what are the terms used in sequencing problem. First one is job. Job is nothing but it is the primary stimulus for sequencing. Next one is number of missions. A mission is characterized by a certain processing capability or facilities through which a job must pass before it is completed end job. Next one is processing time. Processing time, it is a time for each job requires to complete the job at each mission. Next one is total elapsed time. So it is a time between the starting of the first job on first mission and the completing of last job on the last mission. And the next one is idle time. So idle time is nothing but it is the time the mission remains idle during the total elapsed time. The next one is technological order. It refers to the order in which various machines are required for completing the job. It is also known as the processing order. The next one is no pausing rule. It implies that pausing is not allowed in the sequencing problem. For example, if each n jobs are to be processed 2 missions A and B, it means that each job will go to A first and then to B. So next I am going to explain a problem. So how to determine optimal sequence and how to find the total elapsed time. So in this problem there are 6 jobs and 2 missions A and B. To determine the optimum sequence and total elapsed time, we should follow the following procedure. So first we need to find the optimal sequence in which the job should be processed on each mission A and B. So the given order of the mission is AB, which means that each job can be processed first A and then to B. So for a sequencing job, so first we need to find the minimum processing time for both the missions A and B. So in this problem the minimum processing time is 7 for job 1 on mission B. So for sequencing, optimal sequencing, if the minimum processing time occurs on mission A, it should be assigned for the corresponding job from left to right. At the same time, if the minimum processing time occurs on mission B, the corresponding job should be assigned from right to left. So in this order we have to find the optimal job sequence. So from the given problem, 7 is the minimum processing time for job 1 on mission B. So it should be assigned from right to left. Okay, then the minimum processing time is 9. So it is a processing time of job 6 on mission B. So it is also assigned from right to left near job 1. So we can do the optimal sequence like this. So we will get the optimal sequence for job. We get the job sequence 2, 3, 4, 5, 6 and 1. So this is a job sequence in which the jobs are processed from mission A to mission B. So next we need to find the total elapsed time. So for this we need a table. The first column contains job sequence and second one is in time and out time of mission A and in time and out time of mission B. So in time is for job 1 is 0 and the out time will be getting by adding the in time and processing time of the job and corresponding mission. So each and every job can be processed first on mission A and then move on to job mission B. So here the job sequence is 2, 3, 4, 5, 6 and 1. So the first job 2 is processed on mission A. So the in time of job 2 is 0 plus the processing time of job 2 is 10. So if we add 0 plus 10 we get the out time of job 2 10. And then second job 3 is started on mission A after 10th hour only because the first job is processed up to 10th hour. So the second job 3 started at 10th hour and the processing time of job 3 is 11. So if we add 10 plus 11 we get 21 is out time of second job. Similarly we can do the out time for all the jobs and then move on to mission B. So the job 2 is completed in 10th hour on mission A only. So after 10th hour only the job 2 is move on to mission B. So the in time of job 2 on mission B is 10. The processing time of job 2 on mission B is 15 hours. So 10 plus 15 is 25. So similarly we can find the out time of all the jobs. Finally, we get 85 as the total elapsed time. The total elapsed time for each 6 jobs on both the machines A and B is 85 hours. Then we need to find the idle time. So, idle time is nothing but the machine is idle during the total elapsed time. So, idle time for machine A can be getting by find the difference between the total elapsed time and the total processing time on machine A. So, the total elapsed time is 85 hours and the total processing time on machine A is 77 hours. If we subtract this, we get 8 hours as the idle time for machine A. So, similarly, we can find the idle time for machine B, total elapsed time minus total processing time on machine B. The total elapsed time is 85 and the total processing time on machine B is 68. If we subtract this, we get 17 hours as the idle time for machine B. So, in this way, we have to find the total elapsed time and idle time for both the machines A and B. Thank you so much.